Find the exact value of the tangent of negative 210 degrees without using a calculator. Okay, this is going to involve the reference angle, and this is a negative 210. The first step is to identify the location and the value of the reference angle, theta bar. So let's draw a vertical axis and a horizontal axis and label the sides in degrees. 0 degrees down to negative. Now you notice we're going negative. We're moving, sweeping down in a negative direction, not a positive. So it's negative 90 degrees, negative 180 degrees. 90 degrees more will give us negative 270 degrees, and 90 degrees more would give us negative 200 let's see, negative 180 degrees. I'm sorry, 360 degrees. Okay, so now we drew the angle starting at the terminal, the initial side, that's a positive x-axis, and we swung around from the bottom to make it negative. And we know that negative 210 lives somewhere between the negative 180 and the negative 270, somewhere in between there. So we stop it there, and we identify that as our theta equals negative 210 degrees. Now, to identify the reference angle, you look at the terminal side that you just drew for your angle, theta. The terminal side is the angle made with the terminal, the reference angle is the angle made with the terminal side that we see here in the second quadrant with the closest either positive or negative x-axis. In this case, it's the negative x-axis. And that measure is negative 180 degrees. So, since we're dealing with negative numbers, we have to be careful and use absolute value. The reference angle theta bar would then be equal to absolute value of the negative 180 minus the negative 210 degrees, which turns out to be a negative 180 plus 210, and the absolute value of that is 30 degrees. So you see that the terminal side and the closest x-axis, which would be the negative x-axis, they together form an angle of 30 degrees. That is our reference angle, theta bar. Step 2, let's figure out what the tangent of the reference angle is. Well, we know we're in quadrant 1, right? And so let's draw it in quadrant 1. Well, what's in quadrant 1? The 30-degree angle, the reference angle, is always in quadrant 1. It's always an acute angle. There's our 30 degrees. It's a right triangle. So what does that imply? Well, we could look at the 30, 60, 90 triangle. Let's write that 60 degrees at the bottom, 30 degrees up at top. Label the sides 1, 2, and the square root of 3. Now look at the 30-degree angle. The 30-degree angle is up on top. The definition of tangent is opposite over adjacent. Opposite over adjacent. Now this is the opposite of the 30-degree angle. That's 1 opposite over, so tangent, 30 degrees, is equal to opposite over adjacent. The opposite of the 30-degree angle is 1 over the adjacent square root of 3. So we see the tangent of 30 degrees is 1 over the square root of 3. Now we haven't simplified it. We didn't rationalize the denominator, but that's okay. We've got our measure, 1 over the square root of 3. That's the tangent of the reference angle. Step 3, let's figure out the sign, positive or negative sign. Well, which quadrant did we terminate in? Now, I want you to look at the original picture in step 1. We terminated in quadrant 2. Right, all students take calculus and circle the letter in quadrant 2. We see sine. What does that mean? That means only the sine and its reciprocal function cosecant are going to be positive for any angle that terminates in quadrant 2. But we're looking for tangent. All right, we have quadrant 2, of course, but we're looking for tangent, not the sine or the cosecant. So we know that our function tangent of this angle that terminates in quadrant 2 can't be positive. It's going to have to be negative. Okay, remember that. The tangent of our reference angle is going to be negative. Thus, let's evaluate the question. Tangent of negative 210 degrees. What is that equal to? Well, let's put a negative sign in the front because we know it's going to be negative. It's the negative of the tangent of the reference angle, 30 degrees. And we calculated that using the 30, 60, 90 triangle. Bring down the negative, 1 over the square root of 3. And if you want, you need to rationalize your denominator by multiplying the top and bottom by the square root of 3. Your final answer would be negative square root of 3 over 3. Okay, so that's what the answer looks like when we rationalize our denominator, which we always should. We should never leave radicals in the denominator in trigonometry.